Tower of Hanoi. Index. Introduction. Objective. Graphical representation. Algorithm using recursion. Introduction. The Tower of Hanoi, also called the problem of Benares Temple or Tower of Brahma or Lucas Tower. It is a mathematical game or puzzle consisting of three rods and a number of discs of various diameters, which can slide onto any rod. The puzzle begins with the discs stacked on one rod in order of decreasing size, the smallest at the top, thus approximating a conical shape. Objective. The objective of the puzzle is to move the entire stack to the last rod, obeying the following rules. Only one disc may be moved at a time. Each move consists of taking the upper disk from one of the stacks and placing it on top of another stack or on an empty rod. No disk may be placed on top of a disk that is smaller than it. With three disks, the puzzle can be solved in 7 moves. The minimal number of moves required to solve a Tower of Hanoi puzzle is 2n-1, where n is the number of disks. Graphical representation. Input 3. Output disk 1 moved from A to C, disk 2 moved from A to B, disk 1 moved from C to B, disk 3 moved from A to C, disk 1 moved from B to A, disk 2 moved from B to C, disk 1 moved from A to C. Algorithm. To write an algorithm for Tower of Hanoi, first we need to learn how to solve this problem with lesser amount of disks, say 1 or 2. We mark 3 towers with name, source, destination and aux. If we have only one disk, then it can be easily moved from source to destination peg. If we have two disks, first we move the smaller disk to aux peg, then we move the larger disk to destination peg. And finally, we move the smaller disk from aux to destination peg. So now we are in a position to design an algorithm for Tower of Hanoi with more than two disks. We divide the stack of disks in two parts. The largest disk, nth disk, is in one part, and all other n-1 disks are in the second part. Our ultimate aim is to move disk from source to destination and then put all other disks onto it. We can imagine to apply the same in a recursive way for all given sets of disks. The steps to follow are: Step 1. Move n-1 disks from source to aux. Step 2. Move nth disk from source to destination. Step 3. Move n-1 disks from aux to destination. Recursion. Tower of Hanoi using recursion. The idea is to use the helper node to reach the destination using recursion. Below is the pattern for this problem. Shift n-1 disks from A to B using C. Shift last disk from A to C. Shift n-1 disks from B to C using A. Follow the steps below to solve the problem. Create a function Tower of Hanoi where pass the n current number of disks from rod to rod aux rod. Make a function call for n-1th disk. Then print the current disk along with from rod and to rod. Again, make a function call for n-1th disk.